cos of 180 degrees plus theta will be equivalent to minus cos of theta. And then tan of 180 degrees plus theta is going to be equal to tan theta. All right? Then, in the fourth quadrant now, so this is the third. In the fourth quadrant, you are going to end up having sine of 360 minus theta. Now sine is negative, so this will give you minus sine theta. And then cos of 360 degrees minus theta will give you cosine of theta. And then tan 360 minus theta will be equal to minus tan of theta. Okay, now for the first quadrant, we can just add 360 and theta. And then we can write this as sine 360 degrees plus theta. This will be equal to sine theta. And then cos of 360 degrees plus theta, that's equivalent to cosine of theta. And then tan theta, so the tan 360 plus theta will give you tan of theta. Okay, because in the first quadrant, the three trigonometric ratios are all positive. So this is the fourth quadrant. Yes.
So why don't you include the 360 is going around kind of like 1,000?
Okay, remember our angles, we measure them positive from first quadrant, from the x-axis, right? So if I go one revolution, then another angle which is acute, that becomes 360 plus 3.
So why not just skip up to 360?
Well, you see, the reason why I'm putting that one there is you are most likely to encounter some questions where you need to know that sine 360 plus theta is equivalent to sine theta. So it's one revolution plus theta. Okay, it's more like if I walk around the class and then I come back to where I am. Okay, so that's one revolution for me. Then if I move another distance maybe up to there, that's an extra. So my one revolution should be from here all the way up to here. That's an extra. Okay, so 360 plus theta is equivalent to theta. The position is the same. Right? Okay. Well, so based on yesterday's lesson with Mr. Danaus and you memorizing this, you should be fine with the reduction. Okay, the reduction formula. Next year, when you do what are called compound angles, you'll find this a little bit easier than now, because at this stage in grade 11, you have to memorize. Okay, but in grade 12, you have to know now based on compound angles. So the basic idea here is that any trigonometric ratio of an angle which is more than 90 degrees can be written using an angle which is less than 90. That's the basic idea here. I'm sure you can see that on the right hand side of these identities, we have got a theta, and our theta there is acute. Okay? Theta is less than 90 degrees. Okay? So we are rewriting all trigonometric ratios of non-acute angles using an acute angle. That's the concept of reduction. And you need to know your quadrants, or rather your cast diagram. Where is x negative, where is x positive? In which quadrant is sine, or rather sine, cos, and tan positive and negative? Okay, for you to be able to understand the reduction formula. All right. Now let's move on to detailed application of this. Okay, so let's start with some examples. Right? Everything that I'm going to be doing here, it comes from this. Okay? So make sure in your maths workbook you have got this information, these 12 identities. For now, we are going to add more. So you need to know you have got these 12. Okay? So that you can be able to answer questions like this. So the first question A, you have got sine 180 degrees minus theta plus sine 360 degrees minus theta. Okay? Now, there is no need to think, you just memorize it. Sine 180 minus theta, if theta is acute, it means 180 minus theta is going to be in the second quadrant. In the second quadrant, sine is positive. Therefore, this will be equal to sine theta plus, now if theta is acute, 360 minus theta will give you an angle in the fourth quadrant. In the fourth quadrant, sine is negative. So this will become plus minus sine of theta, which will give you sine theta minus sine theta. And the answer will be a 0. Okay? Please be aware, theta is acute between 0 and 90 degrees. Okay? Alright? Okay, so let's move on. The rest is just application of your knowledge of algebra and other concepts. Right? So let's do like tan, like number C, or rather C, but tan 180 degrees minus A over tan 180 degrees plus A. Okay? This is not complex. So if A is acute, 180 minus an acute angle will give you an obtuse angle. Right? And that obtuse angle obviously will be in the second quadrant. In the second quadrant, tan is negative. So this will become minus tan A over, now 180 plus A, if A is acute, add it to 180 to get an angle in the third quadrant. In the third quadrant, tan is positive. So the answer there will be negative. Are you following what I'm doing? Right? Then let's do one more complex one, like the one with the square. Right? H. I can't do every question. So H, you have got sine squared of 360 degrees minus theta times cos squared of 360 degrees minus theta. This is all over sine 180 plus theta times sine 180 degrees minus theta. Alright? Now, first, since this is your first lesson on using reduction formulae, I'm just going to take you to basics for the numerator. Okay? Sine squared 360 minus theta is the same as, sine 360 degrees minus theta, like this, all squared. Okay? Please take note, this sine squared of 360 degrees minus theta, it is the same as finding sine 360 minus theta first, then you square the answer. Okay? So this is the same as that. Okay? Then times cos squared of 360 minus theta, which I can rewrite as cosine of 360 degrees minus theta all squared, like that. This is all over. Now, I want you to know that every time you get something like this, okay, just give me a second. Every time you get a trigonometric expression like this, you always get a positive answer. Always. If you get something like this, as long as there is a square there, you always get a positive answer. No negative answer. Okay? And your positive answers for sine 360 minus theta all squared, you get sine squared theta. And here you get cos squared theta. And both will be positive. Okay? So the denominator, sine 180 plus theta. If theta is acute, this whole angle will be in the third quadrant. Okay? And in the third quadrant, sine is negative. So I have to write this as minus sine theta. Okay? Times. Can you pay attention? And then 180 minus theta. If theta is acute, okay, this whole angle will be in the second quadrant. Therefore, sine 180 minus theta is equivalent to sine of theta. Yes. Yeah, theta is always acute. Or if you get another letter, whether a Greek letter or an English letter, that angle will be what? Acute. Okay? Now let's simplify the numerator. So the numerator, first, what is sine 360 minus theta? It's negative what? Sine theta. Right, so let's write that. It's your first lesson, that's why I'm doing this. So that gives you minus sine theta squared times, what is cos 360 minus theta? That will give you a positive cos theta. Okay, squared. Right? Then the denominator, minus sine theta times minus sine theta will give you minus sine squared theta. I think I need to tell you this. Trigonometry requires algebra, the knowledge of algebra. Okay? So this sine theta, you can treat it like x. The sine theta can treat it like x. X times x gives you what? X squared. But there's a minus there. But in trig now, we don't write the 2 on the right hand side of the theta. We write it between the word, the acronym for sine. Remember, this is a shortcut. I hope you know that SIN is a shortcut. The full name is SINE. You know that, eh? If you didn't know, the full names of your three trigonometric ratios are sine, cosine, and tangent. These are the full names. Okay? These are the full names. Okay? So SIN is just a shortcut. Okay? So here it will be minus sine squared theta. Okay? I hope you saw how I moved from here, then there. Now I got here. I'm simplifying now, so you get sine squared theta times cos squared theta. Please don't put this 2 on the top right hand side of the theta. Please, if you do that, the meaning becomes different. Okay? The 2 must be between the SIN and the theta, and it must be a superscript. Or you can maybe say an exponent if you want. So all over minus sine squared theta. Alright? right? Now your algebra now must kick in now. There is sine squared theta, there is sine squared theta. So what happens is that these two, okay, can cancel out. You've left the negative one in the denominator. Then cos squared that divides by minus 1.
Isn't that something negative with the top sign?
It can be negative because minus sine theta times minus sine theta will give you positive sine squared theta. So the numerator will never have a negative. It's a very common mistake. That's why I'm explaining every step there. That's a very, very common mistake. Even mathematics, when they were writing the June exam, they were making, some of them were making that mistake. This sine squared 360 minus theta will always be positive. It will never be negative because of the square. Right? So the final answer here is going to be minus cos squared theta. That's the final answer. Okay? So here, I didn't skip any step. I took you to the basics because we are still starting the topic. I don't want to make assumptions. So this is how you should do the question. Any question? Any question so far? Are you all okay in front here? You're okay? Okay, this side, are you okay? Yeah, your assignment on the 26th might have this, plus the geometry, and your pass mark is 40 out of 50. All right. Okay. Let's move on to negative angles. All right. This part here is very important for you to know. Your angles are negative if you measure them from the x-axis in a clockwise direction. Right? So if I draw a terminal ray like that, I can call this angle here minus theta. Okay? Now, all negative angles are negative measured from the x-axis in a clockwise direction. They are positive measured from the x-axis in an anti-clockwise direction. You must know this difference going forward. Positive, anti-clockwise. Negative, clockwise. Right? Now, all negative angles can be converted to positive angles. All negative angles can be converted to positive angles that are acute. Therefore, if you are given sine of minus theta, if I have to take you to the basics, okay, let's just simplify that. So, sine of minus theta, okay, we can rewrite it as a positive angle by adding 360 to that theta, to that minus theta. So if I am here in the first quadrant and I move, okay, if I move 160 degrees from here, I'll come back to the same point. Okay? Be aware of that. But if I add 360 from here, okay, or let's say if I add 360 from that point going all the way, I'll get to the first quadrant. Okay? So sine of minus theta, I can add 360 to it. If I add 360, this will become sine of 360 degrees minus theta. And we know what this is. It's equivalent to minus sine theta. Okay? So sine of minus theta is the same as minus sine theta. That's what you got here. Okay, please be ready today. You have to memorize quite a lot of things. Okay? So the sine of a negative acute angle is equivalent to minus sine of the positive of that same angle. So all you have to do here is, instead of having this minus theta on the right hand side, you just write the same acute angle as a positive angle, then you put a minus in front of the sine. Okay? Then for cos now, cos is quite unique. Okay? Cos is unique now. Because we already know that minus theta is in which quadrant? Fourth quadrant. In the fourth quadrant, is sign positive or negative? Positive. So, if I take you back to the basics, the cosine of minus theta will be the same as the cosine. We add 360 to that angle, we'll end up getting the cosine of 360 degrees minus theta. And this is the same as cosine of theta. Okay? Yeah, be very careful of that one because you can make a mistake of saying cos minus theta is equal to minus cos theta when it's not correct. Cos of a negative angle is always equivalent to the cos of the positive of the same angle. Okay? Alright? Or any angle actually. The cosine of any negative angle is equivalent to the cosine of the positive of the same angle. So cos 300 is equivalent to cos minus 300. You can check that with your calculator. Then tan is the same as how I did sine here. Let me try to write on top. So tan minus theta is the same as tan minus theta plus 360 degrees. And that will give us tan 360 minus theta. Now we are in the fourth quadrant. Okay? Remember, minus theta is equivalent to 360 minus theta. Be aware of it. But 360 minus theta is a positive angle. Minus theta is a negative angle. And this will give us minus tan theta. So, just to summarize this, you need to memorize this. Okay? The sine of negative theta is equivalent to minus sine of theta. Cosine of minus theta is equivalent to cosine of theta. Also, tan minus theta is the same as minus tan theta. So you have to memorize these three for your negative angles. Okay? If you forgot, go back to the basics. I've shown you how to derive it. Go back to the basics. If you can't memorize it, just go back to the basics. Okay, so we have got 15 reductions so far, right? 15 of them, right? The first 12 that I drew on the cast diagram, and then we have got 3 for negative angles. Can I carry on? Any question? Okay, I have already given you these 3 on the cast diagram, so I'm not going to talk about this. This is when you have got an angle which is slightly more than what? 360 degrees. Okay? And that angle can be written as 360 plus theta, and then you can have your reduction. All your 3 trigonometric ratios will be positive. So I already gave you this. It's in the first quadrant if you drew my cast diagram. Okay? So it's the same thing. Now, sometimes you can get 2 revolutions plus an acute angle. The same concept applies. Like, for example, if I give you, say, sine of, okay, let me have an angle like 490 degrees, okay, like that. Sometimes you might need to reduce that more than one revolution angle to what? Or a non-acute angle to an acute angle. So first thing you have to do, subtract 360 from this angle. So that becomes sine 490 minus 360. So if the angle is more than 360, subtract a 360 first. If it's more than 720, you can subtract 720. If it's more than 1080, you can subtract 1008 because 1008 is 3 revolutions. Okay? So here you end up getting sine. Oh, that will give me 130. Okay? So we are now in the what? Second quadrant. Okay? In the second quadrant, sine is what? Positive. But this angle here is not acute. We have to convert it to an acute angle, so we subtract it from 180. 180 minus 130, that will give you sine 50 degrees. So that will be your answer. Are you following that? So that's how you work with revolutions. You subtract 360 first. If there's still an angle more than 360, then you can subtract another 360. But if you can know that one revolution is 360 degrees, 2 is 720, 3 is 1080, and then 4 is going to be 1440. Then if you get an angle which is more than one revolution, you subtract 360. If it's more than 2, you subtract 720. If it's more than 3, subtract 1008. But in most cases, you only get an angle which is more than 360, but less than 720. But in rare cases, you might get more than 2 revolutions. But those are rare cases. Okay, so that's what you have here. It's exactly as what you got in the first part, but sometimes you might get an angle, like in this case, it's in the second quadrant. That's sine 130 there. Okay, you might get one which is in the third or in the fourth, but the concept is still the what? The same concept. Right? This is the same concept. Now, what if now you do a subtraction of a negative angle? Okay, like in this case, if you subtract one revolution or 2 revolutions and so on. The concept is still the same, right? Let's say if I give you an angle like sine, okay, if I give you an angle like sine theta, okay, let me just give an angle, specific angle. Let's say 50 degrees, okay? If I subtract 360 from this, okay, just doing this for interest sake. If I subtract 360 from that angle, I hope you know that this minus, it means I'm going clockwise, okay, from the first quadrant. That's what it means. So I'm in the first quadrant. My angle there is 50 degrees. And if I'm going clockwise, 360 degrees, what that means is I'm moving from here all the way up to there. Okay, actually it's from here all the way up to the same angle. Okay? You following what I'm saying? So if you move 360 degrees clockwise from 50 degrees, you come back to 50 degrees. So sine 50 degrees minus 360 is the same as sine 50 degrees. It's the same. But let's do a mathematical derivation for that. To do the proper mathematical derivation, this will be sine. Okay, allow me to swap the two. So I can write this as minus 360 plus 50 degrees. You're following that, right? This will be equal to, allow me to carry on, then I can give you a short break. So sine 50 minus 360 is the same as sine minus 360 plus 50. Then let's factor out minus 1. We want to go back to the basics. So this will be sine minus, okay, let me put a square bracket there, minus 360 degrees minus 50 degrees. Okay? You following what I just did there? I factored out minus 1. I'm going back to the basics, the cast diagram that I gave you with the reduction. That's where I'm getting to. So here, this minus, I can take it to the front, I can take it out. If I take it out, I'll end up having minus sine of 360 degrees minus 50 degrees. Okay? Now the question is, what is sine of 360 minus 50 degrees? It's going to be minus sine 50. So we are going to end up with this minus, then we open a bracket, okay, we write minus sine 50, okay? So this, okay, okay, let me do it on the next page. So that will become minus, open bracket, minus sine 50 degrees. And this will give us sine 50 degrees. Yes? Okay, let's take a break. But you only have 5 minutes. No, the next step will be open from Monday. From Monday.
So how did you get from sign the 130 to
You see here, from 490, I subtracted one revolution.
Yes.
Because this is less than 720.
Yes.
Then I got 130. Right? 130 is in which quadrant?
Second.
Second. But it's not acute. So how can we rewrite it using an acute angle?
So you said
With minus 130. Remember, the objective of reduction is to write our acute ratios using what? Acute angles.
Thank you. Sorry.
When I went to school, we were not doing those. Okay, for sciences, yes, that's when you're doing practical. But the physics and chemistry practicals are a bit different from the page for subject like tourism, EPD, and all that. Yes.
The negative because it's in the book. And the 360 minus drops because you remove you get it now. Right already. Yeah, probably keep it there.
Only writing one sentence. All right. Is everyone back? Who is still outside? Okay, unfortunately, the 5 minutes is over. All right. So, besides what I showed you here, we can also do it using a second way, class exercise. So, your class exercise, you need to do question I and J. You can refer to the class diagram and all the information you have so far. So, write class exercise and copy down I and J. Do those two questions quickly. I and J.
I know what I'm doing, but I don't.
Have you finished? If your math workbook is up to date, then you should be able to refer to the information you got yesterday and also today as well. Huh? What? I can't hear you properly. I was here yesterday. Yeah, I had some personal things to sort out. As teachers, we have got personal lives here. So I had an urgent personal matter to sort out at that time.
What I did now too.
All right. Can I have your attention? Well, I might give you a short test on geometry just to see where you are individually next week. Right? I think I have to probably arrange for that maybe after school because we've got lots of work. What? Huh? It will be a short test. Maybe just give you two, 3 questions. It's not gonna just to see. Right? How many of you have finished the question?
I did too.
Okay.
Just read that one. For which one? I got one to 10. Let's see how. And then for J, I got -1. How are we off by a minus sign? Oh, so algebra. That's why. Check your minus sign. Remember your algebra. I'm looking at it. Oh, J is 1. It's just memorizing weird. Oh, J is 1. The second that I look at them, I get it. These days I'm having my math. No idea why. Like how do you know what I'm doing? Does that make sense? Like you get into like these days I started but how did you get minus 10? The biggest sin is something like this.
Alright, have you finished? What's the problem?
Going to something. Every single
Okay, let's go over it quickly.